Hey everybody, I'm Zach.
And I'm Jesse.
And you're watching In Depth.
Oh, now you know. Brought to you by abetterrootplanner.com. Use our link in the show notes below to get a 30-day free trial to the premium app.
And we're sponsored by BigBattery.com with the best battery prices in the USA, guaranteed. If you've got something you need to power from homes to cars, RVs to boats, and much more, BigBattery.com has you covered, offering the newest battery tech. Use the code NOWYOUKNOW to save 5% off your purchase today at BigBattery.com.
And if you like the new shirts that Zach and I are wearing, you can go check those out at EcoWear. You'll help support the show. You will also have your entire order completely carbon offset from the manufacturing, the shipping, and the life cycle. And we'll plant a tree for every order. And we'll help cap a well for every order. So head over to ecoware.us because there are tons of great products and it's a really great company.
All right, so we wanted to talk today about battery recycling.
For the longest time, they weren't recyclable. They were probably these alkaline batteries.
They come fully charged from the factory. You bought them at the store. You popped them into your watch and your electronics and your smoke detectors. And then they eventually ran out of charge and you either threw them in the trash or you did the right thing and you brought them to the store or your local collection center and you threw them into one of these cardboard boxes that says, recycle your batteries here.
Now, fast forward to today, most of us are probably using rechargeable batteries more and more, nickel metal hydride and lithium ion. Those cardboard boxes are now accepting cell phone batteries, laptop batteries, power tool batteries, pretty much any kind of battery you can think of.
And after dropping off your battery to be recycled, you walk out of the store and you feel pretty good about yourself, don't you? Because you just did your part to save the planet.
I know that's how I felt.
But recently, we spoke with Erica Guerrero and Luke Workman from Redi-Vivus, a new battery recycling startup. And I realized I was largely fooling myself. Most of these cardboard boxes of batteries don't miraculously get recycled into new batteries.
Many early lithium battery recycling company's business model was basically to collect all the batteries you can and leave them in a dumpster, a metal dumpster outside until it burns, and then you get insurance payment on the losses of what you had. And that's kind of the, an unfortunate blight in the industry, and we're trying to change that to make real recycling that works.
Wait, what? So the plan was to just let them catch on fire and then file for insurance?
Well, think about it. As Erica and Luke are going to explain, batteries are actually pretty dangerous. I mean, especially when you don't know what's happened to them. I mean, that battery that you've had in your flashlight or your power tool, well, you know where that's been, right? You know it hasn't gotten too hot or gotten punctured.
But you don't know if the batteries have been quietly corroding in their plastic case.
And when you got a big cardboard box of batteries in a store that have come from hundreds of people from all over, all in different conditions, if just one of those batteries is ready to have a thermal event and explode or leak, it could turn that whole box of batteries into a big fire, which kind of makes you wonder why they're using a cardboard box to collect them in.
And that's a relatively small number of batteries. Think about maybe like a car accident.
Yeah, so the car wreck lets you get into, God forbid, a car wreck with your Chevy Bolt. And now, usually, if it's completely totaled, it goes to a junkyard. These people have been doing junkyard things for many years, sometimes many generations. And this is the first time that they're dealing with packs that are high enough voltage that if you touch them while they're damaged, they could kill you.
Yeah, so I think we've kind of been kidding ourselves. I mean, all of us EV lovers watching this, we've been passing on the charts and the infographics to our friends of how we're just going to take all these growing number of EV batteries and just recycle them into new EV batteries. Magic.
I know I wanted to believe it, but today just 5% of all lithium-ion batteries actually get recycled. When I heard about Redwood Materials, JB Strobel's new battery recycling company, I was like, yes, see, it's all taken care of. JB has got this.
But then after talking to Erica and Luke, who are experts in this space, I realized that I hadn't thought about some of the details. See, Erica and Luke have worked on this problem from the other side of the equation.
It was more like guilt forced us into recycling. I don't know.
Well, when he says guilt, I mean, because we've built so many batteries, like prototyping is so much fun, right?
And R&D.
But bringing things into production is like hell, right? That's what you usually hear, right? But the issue is that if you don't take care of these issues we talked about today at an early stage, then you just have the same problem at a larger scale. So when you create a lot of e-waste and you're just looking to other people to solve the issue that you've contributed to, a lot of times you really have to be able to solve your own problems.
Yep.
You can't just necessarily ignore it and think someone else will do it, because that's kind of like the bystander effect.
Yep. Since 2011, when I started first making R&D battery scrap waste, at a professional level of making battery R&D testing, I thought someone's going to get on this waste scrap pickup real quick, and these things are going to be hot commodities as little ore treasure troves in a box, of valuable materials to recycle. And still waiting for someone to come in with a good process that's efficient and clean for the earth and makes sense. And so started cracking that nut ourselves eventually, and cracked it wide open to a point that comfortable and confident with the process and efficiency and materials returned.
And I think that this is super important. Erica and Luke didn't set out in life to form a battery recycling company.
Right. I mean, Erica worked for SpaceX and Romeo Power, and Luke worked for Microsoft and Zero Motorcycles.
They were busy making the best batteries and testing them to make sure that they last as long as possible.
They understood the battery industry from that side and realized there was a problem. There was nobody truly recycling these batteries.
They also understood a fundamental problem, especially with big EV packs. They are super dangerous and super expensive to transport when you don't know what's going on with them.
Our solution to that was, instead of putting more people at risk, like your logistics people to come and you pay tens of thousands of dollars to get the right permits, to get the right training, to bring it onto a truck, to drive it somewhere else, and then you're putting people on the highway in danger because you don't know the status of this.
I mean, we've all seen the accident sites, right?
An EV gets into a car accident, and we've seen the videos and photos of EVs being winched onto a flatbed truck to be transported to the junkyard.
And we've heard the stories of EVs reigniting a day later, even after it's been extinguished by a firefighter.
Battery packs that have been damaged can be dangerous.
And they really shouldn't be transported at all. I mean, these batteries are federally designated as Class 9 hazardous materials.
A typical car mechanic transporting a busted EV on a typical flatbed who doesn't know anything about their chemistry and who hasn't been properly trained, it's just not a good idea.
That's exactly right. And there's no PPE that exists that you could put a worker in to have them near it. If you do the arc flash calculations for these kinds of tests, there's absolutely no PPE that provides you resistance. There's just levels of severity you'll be injured in that situation.
Well, now I'm all depressed. I mean, there's no solution. We just made all of these ticking time bombs with no hope of recycling them.
Well, hang on. That's the first half of the story. We've now come to the part of the story where Erica and Luke tell us that they have a solution.
Our shredder process is, it's called redi-shred, and that is our way of being able to make the batteries safe, to go ahead and shred them.
Once the pack is out, in whatever shape they extracted it, and with whatever parts of the car members still attached to it, let's say, then provided it fits in the mouth of the shredder, we'll shred it, and we don't need to take it apart any further than what it takes to fit in the mouth of the shredder, which is a very large mouth. We can shred Tesla packs whole.
Now, hold on, hang on. Wait a second, because every single lithium-ion battery cell that I have ever seen, either on the pack or even if it's a little, cell phone battery, will say, do not puncture, do not crush, be careful, don't do anything, don't shred it. That's definitely something that they don't want you to do. Isn't it going to explode and catch on fire?
Maybe like 15 years ago, I was making YouTube videos of every kind of way you can torture a battery, from stabbing things through them to torching them to cutting them in half and everything in between. But there's actually a trick that you can render the thermal kinetics so slow that your time constants aren't a problem for shredding them. Well, if you took that same battery and you left it overnight on dry ice, let's say, just as an example, and then in the morning you pulled it out, and while it was still very chilly, you did that same torture you were going to do, sticking your scissors through it or whatever you're going to do, you would find there's this period where because ionic behavior, the ability for the cell to make current and generate heat is effectively limited by temperature in the thermal kinetics of diffusing ions. And so for every 10 degrees cooler that the cell gets, you have roughly half the rate that this current generation chemistry can occur. And so when you're at, say, minus 60, the rate that this current production can occur is almost nothing. If you put that battery at minus 60 in your flashlight or whatever, and you turned it on, to use it, it would be like the worst performance you've ever seen, from a ionic potential. In fact, it might not even be able to light your light bulb, right? It might not even be able to make like 1/2 amp to light your light bulb. And so that's also why it's inert to the shredder and behaves completely different at those temperatures than it does if you were to shred it at room temperature.
Okay, so now I get that you cool it down and you can shred it safely without it catching on fire. But then you're left with a pile of battery confetti on the floor, which is warming up. And as it warms up, those chemical reactions are going to happen. You've only delayed the inevitable. How do we prevent it from just catching on fire once it's ground up?
The shreds all fall into an aqueous pH buffer neutralizing solution. And that's why even if, let's say, you get some hot pieces that are coming out, maybe some part of the cell wasn't completely blast chilled, it falls and just makes a little, as it boils water for a split second, and the energy is released. In this tank, there's the right mix of ionic diffusion paths to allow everything to reach a common entropy level of chemistry state. Yeah, essentially, that's why we can take any state of charged battery, and we know that before it's ever dry, so before it's ever out of our pH aqueous brine solution, it has already realized like a zero entropy, where it's as non-dangerous as bits of aluminum foil or copper foil you might have laying around in your kitchen or whatever. It's as unlikely to cause a problem as those materials afterward.
So that's great. The battery is now in a safe state, but we haven't recycled it yet. It's just a slurry of junk.
Well, hang on. We're not done. Well, I should say Erica and Luke aren't done. After they shred it, they're working on another step called redi-cycle.
Second part of our company, which is called redi-cycle, REDI-cycle, and continue to get those materials. And Luke can definitely get into this, but in the layman's terms, like, we deeply respect and admire the recycling companies that are out there right now. It's a humanitarian issue. We definitely need it for the planet, like we said. We really would love to see the smelting process removed. And that's just burning and melting all of these things, because there's a lot of energy that goes into that. There's also just like gases released, so you need to scrub it a lot more. And that's essentially one of the major things that we look to in our process at the recycling stage to get rid of.
Nice. So Erica and Luke have come up with a way to shred a battery and then recycle it. According to them, you can get back 92% of the nickel and cobalt, 75% of the copper, 90% of the iron, and 90% of the lithium. And unlike J.B. Straubel's process, there is no big crucible of fire.
Yeah, we have no roasting before smelting and no smelting. So two processes that are normally thermally done to process batteries, and we've managed to eliminate both of them by using significantly more earth-friendly processes. One of the output products is 99.99% pure nickel, metal form.
It's pretty cool. Like, we took Tesla batteries and then we just received strips of nickel.
It was a lot more work than just receiving it. I think it was like
black box. You
it was like a month of You get nickel, cobalt, manganese, copper, aluminum, steel, lithium, and even fluoride salts all out as processes, because everything that's in the cell has to go somewhere, right? And so if we don't have it as an output material, then it's a waste stream that accumulates, right? So we have to have everything that goes in the cell as a output material ultimately.
You've probably heard this too. It becomes a material science problem, or opportunity, really, because there's so many different polymers and different kinds of metals of different purities that you can find a second home for. And I love thinking about using geopolymers to like capture carbon in the air somehow and like make houses out of it and things like that.
The polymer scrap is actually good for doing something like a geopolymer application. But that's a whole different business on its own that would be just as big or bigger than the recycling business. So
And that's our
I wanna-
strategic partners as
Yeah.
well that we're
that's for other
teaming up
companies
with.
to do. We want to just focus on recycling batteries.
Yeah, of those 5% lithium ion batteries we talked about that get recycled, almost all of them today end up in a smelting furnace.
Many of us have seen this footage of Inside Redwood Materials with their furnace that melts the battery materials to get them into different states of purity. And the problem with that is, one, you have to use a lot of energy to melt them up. Two, you release emissions that you have to capture and filter and clean because they're not, I'm not talking CO2 emissions so that you can just dump out in the air. It's toxic gases that you don't want actually escaping into the environment. And then three, you burn up a lot of material that is no longer recyclable because it's smoke. So it's really great that now we have a system where we can take the batteries and recycle them. And for me, I've always been thinking that we're going to take all of these batteries. Once they're done being used, we're going to grind them up and then we're going to turn them right back into batteries.
Well, that's not exactly what Erica and Luke are thinking of doing.
What we're saying is definitely different than what the industry is talking about, right? You get a lot of those flowcharts that show that circular battery economy, which is definitely a good place to get to. But going off what Luke and I have been talking about is that there's batteries there today that we need to do something with. And this is our opportunity to start gathering those and doing the research and development and putting those materials back into places where they could use those lower purities. And it makes sense to the people who are counting their nickels and dimes, which is very important in business. And then go from there to eventually, hopefully, getting back into the battery economy. But I know a lot of other people are focused on that as well, too. I just don't know as far as where our technology is, if we're going to be able to do that right away.
Yeah, at the moment, there's ample buyers for nickel that is slightly lower purity than battery grade purity.
It's also much different to be recycling right off of, let's say, Panasonic's battery line, where when you build cells, you have a bunch that fall out for quality control. And if you're able to get those jelly rolls or those materials and those layers right directly off of that and recycle it, it's a very much different process than getting your crash bolt battery, which has all the different parts surrounded on it, and it kind of cuts that human factor into it.
Yeah, so using Erica and Luke's redi-cycle process, you still get the materials back, but they admit that some of the materials are not at battery grade. But think about it. Who cares? Let's take nickel, for example.
For our process, the costing doesn't make sense to refine it so highly to be battery grade again when the processing is significantly lower cost and faster to make, say, 99.99% pure nickel instead of the battery grade purity of nickel.
And that's actually better for our process and for our strategic partners that we are going with, because nickel is actually going to be a very high commodity item.
The cobalt in the nickel isn't as appreciated as you'd think from a metallurgy perspective, for some strange reasons, including one of them being that superalloys sometimes are used in places where they're irradiated. And so nickel works for superalloy material in that application, but if you have cobalt in it, then it makes hazardous isotopes from that exposure. And so sometimes cobalt is a penalty, and other alloys embrace cobalt, as for its strength and toughness and chemical resilience, in the alloy.
But it's a niche market that's growing
That's
at
right.
between 8 and 20% a year. So as aerospace continues to grow, there is going to be that need for the nickel and cobalt feedstock. And we plan on giving it to them.
Right, so you still need nickel for making stainless steel, and you don't need it at high purity grades like you do for batteries. And putting all that extra work into refining it back into battery grade doesn't make any sense if there are people who are willing to buy this recycled nickel to put it into stainless steel. So, as long as it gets recycled into something, that's much better than it just, being a class 9 hazardous substance.
And the concentrations of elements that you get from recycling battery cells is way higher than from raw ores that you mine out of the ground. So at this point, I'm already feeling really thankful that there are people like Erica and Luke on the planet.
We've gone from learning that we don't currently have a great battery recycling solution to hearing that Erica and Luke have developed a system to transport and recycle batteries safely safely and cost effectively.
But I want to go one step further, or at least it sounds like Luke and Erica are thinking one step further.
I would like to be developing our next generation recycling process in 5 years, which is entirely biologically based and done by GMO modifying nickel complexing bacteria, cobalt complexing bacteria, and copper complexing bacteria. People already use it for bio-leaching for mining copper today, but fairly recently, some Chinese university made a cobalt leaching bacteria as well. In 5 years, I would love to see a football field sized leach pond facility running a bio-leaching process that's incredibly green and incredibly efficient, handling all the world's e-waste of all types, electronics and batteries, and having low-cost, high-quality output materials from this bio-leaching process. And that would be, maybe my 5-year dream, right?
The scale gets pretty intense really quickly. By 2030, based on our calculations, we think there'll be somewhere around 230 gigawatt hours worth of battery material to be recycled. And just to help you understand the weight of that, that's probably around 20 million metric tons of waste. And so, we think it's going to take around 7 redi-shred trucks just to service the United States and the different regions and whatnot. But as far as doing large scale, we think it's going to even go up to maybe 2.5 terawatt hours of stuff to recycle by the time it gets to 2050. And so as that just gets so exponential, you kind of have to start thinking about changing the paradigm a little bit.
Whoa. All right. So we're talking about like wastewater plants, but instead of treating wastewater, you pump in battery sludge from these shredded batteries, and then bacteria output finished materials like cobalt and nickel. This is mind-blowing stuff.
So it looks like we've gone full circle. I mean, you started by saying how, great you felt about battery recycling. Then you shared how you felt after we learned about the current tech or the lack thereof, and how, battery recycling these days really isn't cutting it. And now we're back to feeling pretty good about the future, at least, of battery recycling.
Yeah, I mean, don't get me wrong. Erica and Luke's company, Redi-Vivus, is a startup. They are just beginning to develop this process commercially. They have proven it works, and now they need to scale up, and we know how hard that step is.
It's going to be no small feat to go from working on this in the lab to scaling this up to work across the country and the world. But these are the companies and people that I, for one, want to support. I can't think of a better place to invest my money.
Well, depending on which one you're really excited about, you can go to redi-shred, redi-shred.com, or redi-cycle, redi-cycle.com. And they'll take you to our company page where you can send us a message. There's definitely info a bunch on the website as well too. And as soon as we begin our talks, we're more than happy to share information as far as what we're working on.
And Redi-Vivus is not alone. There are other battery recycling companies starting up like redi-cycle that are planning on doing battery recycling differently than other companies. Redi-cycle is constructing a $175 million plant in Rochester, New York, as we speak, that will be the largest lithium-ion battery recycling plant in North America when it's completed, and will recycle 25,000 tons of input material and get back 95% of the cobalt, nickel, lithium, and other valuable elements. Oh, and one more thing. I think I'd be remiss if I didn't point out that these two mild-mannered scientists that you've been watching are actually badasses.
What do you mean?
Well, check this out. Luke designed and built this DIY electric Death Bike 7.0. Yes, that's him in 2014 beating a Tesla Model S P85 in the quarter mile.
Not just beating, smoked it.
Smoked it. And he built it.
Yeah, and all of those exploding battery clips that you saw earlier, that was Luke on his YouTube channel over 10 years ago, testing batteries with screwdrivers, fire, crossbow bolts, and hammers. So if anyone knows what blowing up battery cells looks like, it's him.
So that was Luke. This is Erica at the drag strip in 2019 riding an electric Zero SRF motorcycle. Now watch as Erica, in the white helmet in the foreground, smokes a red gas-powered Ducati 959. I just thought I'd leave us with that. Two of the most badass scientists that I've ever had the pleasure of meeting. And these are the people who are going to change our world for the better, and we need to support them.
So if your interest is piqued and you want to hear more from these guys, you can head over to the Disruptive Investing channel, which is a channel that we've set up where we have the full-length interview with Erica and Luke. And I just want to say that like so many of these new companies that we hear about springing up seem to be started and run by people who don't really understand what they're talking about. I'm not really talking about like JB Strobel necessarily, but there's lots and lots of companies, and some of them just seem like they have like an MBA degree and they're like, we're going to make money if we say that we're going to do this thing. So it's really refreshing to see two people who have already been deeply involved in the past decade of this battery transition, who really know this stuff inside and out, take the lead on battery recycling.
Yeah, and I want to stress, this is where I think Redivivus has a huge advantage with redi-shred, a mobile solution that I have not heard of anywhere else in the industry, because it's one thing to deal with the batteries once they make it to your plants, right? It's entirely another thing to get them there safely. And as the number of cars and of car crashes increases, we're going to have to deal with this problem because we're at the beginning of this problem right now. We barely even know that it is a problem, and these guys have already come up with a potential solution.
Yeah, it's really easy to imagine batteries as these perfect things. You put them in the car, and then the car drives around for 10 years, and then you can take them out of the car, and then you can, use them in lots of other fun applications as they slowly degrade over time. And then when you're done, whoa, that's great. We'll take them back, and we'll take them all apart, and we'll unscrew the lids, and we'll unroll the jelly rolls, and we'll scrape off all the stuff, and we'll put it in a little bin, and then we'll just sprinkle it into the new batteries, and presto, you've got brand new batteries, right? That's, I'm going to be honest, how I was picturing battery recycling for the longest time. I was not thinking about corrosion issues in cars and scooters and laptops. I was not thinking about cars that got into accidents and how it's really difficult to move them from that point, at least legally and safely, because they're just fire bombs waiting to catch on fire at a moment's notice.
Yeah, so I just want to go through the process one more time here, because I think it might be so simple sounding, but yet it's kind of amazing that they came up with it. Let's first start with redi-shred. A mobile truck pulls up where they figured out how to cool down the battery somehow. We haven't seen it yet. And because the battery is now cooled down, it's not very dangerous. They shred it all in one time into an aqueous solution that makes sure that all the pieces of that battery are not going to explode later. Then you can now transport that cheaply to a redi-cycle spot, where those materials are then extracted and stuff is done to them so that you can then get all the raw materials back out to pretty much ready to go, maybe not in new batteries, but in other processes.
And it's important to keep in mind that while like the nickel isn't battery grade that they're able to get out, you can refine it.
Yes.
It's not like you're stuck. It's that you could refine it if you want to. At the moment, it doesn't make any sense to do that. It makes more sense to sell it to stainless steel companies. But in the future, when nickel prices have been going up, as that continues to rise for battery grade nickel, it becomes more and more cost effective to refine it, because it's like, well, I can sell it for more.
Yeah, and I just think, going back to the redi-shred truck, this is the first time we've heard of this solution, because right now it may not seem like a big deal. I mean, how many EV crashes have you seen? Not that many. But when we switch our entire fleet around the whole world from 1 billion ICE cars to 1 billion EVs, we're going to have a solution where we can get those batteries back safely and recycle them. And these are the only guys I've ever heard who have a solution for that.
And I think it's because they know from tip to tail what batteries look like, what the life cycle looks like. I mean, we've put together a battery pack sitting right there, that little blue looking bomb thing. And
we have no plans for how to recycle it.
Right. We haven't gotten to that point yet. So I think for a lot of people who even are like building electric cars, it might not be so obvious that recycling them is going to be as big an issue, because you kind of think, well, I put all the things into the car, or I put all of the things into this laptop and I shipped it out, and I should be able to get them all back safely. And it's like, that's not always guaranteed. So it's really helpful to know that there are people who have gone through the whole thing and know that it might not work as perfectly as we all think, and make a solution for that.
You know, it'd be cool is if in the near future we could take that pack with us, go visit Erica and Luke when they're ready, throw it into their shredder and see what happens.
Yeah, I would love to get some nickel strips back out of it, and then we could learn how to make stainless steel. Well, thank you so much for watching this episode of In Depth. Again, if you want to see the full interview with Erica and Luke, you can head over to the Disruptive Investing channel and be sure to subscribe because we're coming out with new interviews all the time over there. Also, if you had wanted to get early access to that interview, you could have joined us over on Patreon. At the $10 level, we have our Investor Club, and Investor Club members get early access to all of the Disruptive Investing videos.
Yeah. Thank you for supporting us because it's through your support that we're able to reach out to people like Erica and Luke, find them for you, and bring you their stories, which I got to tell you, took months to set up.
Yeah. So if you've made it this far, before you click off onto the next video, hit that like button. It would really help us out. We'll see you next week. Now you know.